Okay, welcome back. So we asked a couple of questions to you guys, and I'm gonna start reading one of them. So we have the answer from one group. So regarding the challenges and barriers that they foresee in local companies, they mention high costs, skill needs, suitability of material, manufacturing speed. I'm gonna go back. High cost,
sure.
Skill needs.
Skill.
I was needed, right?
Skill needed, yes.
Okay. Suitability of material, manufacturing speed.
Manufacturing what?
Speed.
Yes.
Low volume.
Yes.
Okay. So that's about the challenges and barriers. And about the expecting date. I mean, depends on the product. So bottling is per unique part in the near term. So it's bottling. I think that's
bottling per unique part
in the near term.
Yes.
Sourcing of products already used for prototyping and design.
Yes.
And that's a furniture. And for airline parts in the near term.
Yeah, I basically agree. The cost is still high. As I mentioned, some big companies, very engineering heavy companies, are investing in this big time. And in fact, GE wants to be a supplier of 3D printers in addition to using 3D printing technology. The skills needed, these are less of an issue. In fact, it's a very interesting subject, because you can think about it, it's basically a robot that is making the machine. You have a digital plan, and then the printer, which is really a robot, makes the stuff. So, and since it's made from one part in many cases, which is just the raw material, it will have an impact on employment. You will need less people. It's not clear that you will need some skills to prepare the digital print, but those are, a lot less than you will need people working on the assembly line. There will be no assembly. So you will need some, maybe, especially to begin with, some manual work to polish items and make them ready for use. But by and large, just like other automation and robotic application, it will reduce the need for people. Clearly, manufacturing speed is still very low. Nothing like mass, I mean, not even in the same order of magnitude of mass manufacturing. And of course, so that's why you can do things only in low volume, and not every material yet. But as I mentioned I didn't mention it, but people are using it for building houses with concrete. In the Consumer Electronics Show in 2017, the last Consumer Electronics Show, there was a car, the whole body of the car that was made with 3D printing. So we can see that the field is moving and getting better. As I say, in terms of the dates, unique item, prototyping, some parts already made. And the question is, how far can it go in terms of speed? How far can it go in terms of affordability of the printer? People my age still recall that to print a document, you needed to go to a special shop. Nobody has a printer on the desk. So, and then the cost of printer came down, just like PC, like just everything else. One can expect the cost of 3D printers to also come down, and the capabilities to become better and better. but it has ways to go. So one, it will take some time before, as I said, it's not clear to me at all. Maybe it's hard to say, but not in the next 2-3 decades, we will have 3D printers at home. Aside from hobbyists, I mean, there's hobbyists, of course. But in terms of in the industrial manufacturing, we will have, one can think about UPS depot, one can think about part of distribution center when items will be printed and sent directly to homes. So we're talking about regional and local manufacturing, but not yet at the home.
Okay, and how about the cost of the materials that are used for the 3D printing? So now they are higher compared to the same material, but for other processes.
I'm not sure the cost of the material is higher because first of all, you need less of it because you have less waste. And you need, if you used to build a jet engine part from titanium, you still need the titanium. I mean, so the material is, I don't think it's, I don't see why the material would be really high. In fact, in some sense, we lower because you use raw material rather than the parts that the supplier already worked on. So you cut down some processes, you cut down tiers of the supply chain processes, so you should have, at the end, a lower cost. Now, right now, because of the time that it takes, because of the printers are still expensive, yeah, it's still expensive. But I don't see the material as
more expensive.
It's expensive, yeah.
Okay, so let's read the answer of the second room. So they talk about training, about costs, redesign, and law and regulations. I think you covered most of them.
Yeah, the training. Well, again, because it's basically robotics, it's robot, I don't think you need much training. I mean, the machine would just build it. So I don't see a large training. Cost is still, the cost of the printer is high. Laws and regulation, yeah, I mentioned this, that you have to find some way to protect the IP. You have to find some much better way to make sure that you cannot control this machine through cyber intrusion, because then you can create havoc in manufacturing. How do you make sure that people are not going to download some designs from the internet and use it to make illicit drugs, or use it to make guns, or use it to make, I don't know what, all kind of illicit products. So for this, maybe some tough standards and tough, defenses have to be designed right into the machines to make sure that the probability of such problems will be minimized. I don't think it can be totally avoided, but at least minimized.
Okay, and also we have a comment about the porosity of the parts that could be a problem.
The porosity of the parts, well, that's usually considered a feature rather than a bug, because you can build parts because of the intricate structure. You can build honeycomb-like structure that are just as strong, or actually in many cases much stronger than existing structure, and weigh a lot less, which is very important, for example, for airplanes, for cars, for lots of products, and that require energy to use, because having to move the weight is most of the energy, takes most of the energy. So I'm not sure that the porosity is a problem. Set costs could be better for 3D setup costs. Setup costs could be better for 3D manufacturing. Yes, in the sense that the setup costs, in some sense, are part of the manufacturing process. So the setup costs are minimal. The problem is the time of manufacturing. Usually, when we talk about the problem with setup costs, is that in mass manufacturing, the time to manufacture each item can be a fraction of a second. But the setup cost between batches is high relative to this. Here, when you talk about manufacturing times in hours and setup costs in seconds, I don't. Of course, the setup costs are significantly lower.
Okay, thank you, Professor. Any final comments that you want to share with the students?
That's always a tough comment, tough question. Well, you see, you guys, it's the young ones among you, are going to live in a world that's the 3D manufacturing is just part of the brave new world. Some of the things that, just like with any other new technology, be it autonomous cars, 3D manufacturing, even mass manufacturing using robotics, we are seeing, by and large, jobs disappearing. And the question is, for society, how do we deal with this as a society? How do we deal with the fact that thinking about 3D manufacturing, there'll be some high-end engineers who will get the digital plans, or at the end, of course, we'll have 3D printers making 3D printers. So how do we make the digital plans for this? But once the digital plans are made, all the thousands of people who are involved in the manufacturing will not have a job. So the good thing is that stuff will still have to move. So some people in logistics will have jobs, but not as many as before. So logistics is still better than many other places to get a job. But it's a problem for societies in general. All this, whether it's 3D manufacturing, all kind of autonomous issue, all kind of robotic-based manufacturing, all of these are eliminating many of the current jobs, and it's not totally clear that it can be replaced one-on-one. Clearly, there will be some new jobs, but not as many. I don't think as many as the old jobs. So society will have to contend with this.
Thank you, Professor, and thank you for being here. Okay, so with that, we're closing this session. Let me remind you that our last, third and last hangout is going to be on Monday, June 19 at 1400 UTC. See you next time.